As far as your dimensioning went yesterday, I hope you had a good day at it without any interruptions from me. Okay, so you got a good full day of drafting in. Was there anything that popped up that you have any questions on? Yes?
Basement.
Mm-hmm.
So, and then we go from the inside wall, because you can't climb up.
That's
But
correct.
You said take out the crawl space, but I only had a 2x4 wall between the mechanical room and the bedroom. I
Okay.
didn't have a concrete space, so I came from the 2x4 wall, which technically would still be the concrete space.
Okay, which way are you going? So you've got your basement. Let me just kind of sketch it. So our basement looks something like this, because we have a bunch of different setups. This is your mech room, right?
Yeah.
Most of us have our stairs coming down somewhere in this
Yeah.
neighborhood.
Okay, so
Okay.
the wall making the L there, I did not have concrete wall on that.
This one and this one?
Mhm.
These are both 8-inch concrete walls. Okay. So if they are not basement walls, then they need to turn into basement walls, okay, which is now. Okay. So make that adjustment. So this wall right here and this wall will be we're going 9 foot with this one. 9 foot on those walls, and they are furred with 2x4s on the inside. So the wall thickness is 10 to 12 inches.
So my dimensions will still be the same, I just don't have, that came off that.
Right, now, when you go and make that change, Lisa, make sure you don't offset this to the
Yeah,
inside,
but the outside, yeah.
because this stairway is probably sucked up onto there, right?
Mhm.
And if you all of a sudden make this wall a foot thick here,
Yeah.
now you gotta move the stairs
No, no,
upstairs.
I get that, no, I'm
Okay.
with that.
Yeah. Okay, so please add that in. And that's the big reason why I do this, is to get this out there, we get good red line on it, we'll check all your geometry, we'll check all your dimensions, and you're gonna get some red lines back.
Okay, so question, do you always offset in?
No, it depends on where your spaces sit.
Mm-hmm.
I can't answer that in a definitive manner. It depends on your spaces. What we do want is that your exterior wall will line up between all floors. And you look at pretty much any building, and that's the way they're all done. Now, we do have cantilevered situations that we do where we can take something and kind of hang it out over space. You see that out there, but that's not a standard process. Generally, we want that outside line to line up all the way. And it basically follows physics, right? It all comes back to the fact that gravity is something we have to deal with. And so you hang something out there without something underneath it, what is its tendency to do? Over time, it's going to fall. Even if you cantilever it and make it strong enough, I mean, if it sits there long enough, it's going to start to fatigue and go. Now, we might be talking thousands of years if we build it really strong, but it's going to do it. Why don't you find many overhangs in nature? I mean, we got a great canyon right here. Does anybody know of any overhang in that canyon?
That one.
One, maybe two that I know of. I know a couple down by Hagerman. But that's it, right? Why? Because rocks fall down when they're not supported underneath them. Overhangs are very rare. Now, can you do them in buildings? Sure, we can do them. Like I said earlier, if we got enough money, we can do about anything. But that comes to be a problem. So I can't answer that. Just line those outside walls up, okay, and then generally you're pretty good.
Okay, no huge question.
Well, Missy's in front of you, so I'm going to.
So how is that supported then? You see those balconies on these hotels that are, 20 feet or however high, and they're just out there. I mean, so you just have,
It's the support going across.
So if I was drawing a wall, and
yeah,
let's say I want to hang something up, what I've got to do to get an overhang like this where I'm not going to support it out here is I've got to do a beam situation here. Now, there's a lot of things on this, and drafters do the prescriptive wall method in the IRC. You folks can cantilever 2 feet and not get it engineered. Okay, so you can do a 2-foot cantilever with the prescriptive wall methods in the IRC. If you go past that, you're going to have to get this engineered. Because there's a lot of things that go on in here. I mean, we have shear, which happens right here. We've got to do some support back here because once you put weight out here, right, it's going to want to do this. And so we've got to hold it, and we've got to do some other things with it. And you can actually get even into a torque situation on these guys. And so you can go 2 feet. Now, if we can take this out quite a ways. Okay, if I put a big steel beam up there, I mean, I can carry that out. Heck, I don't know. I think the furthest I've ever gone is 10 feet. But I know they do bridges that go quite a bit further than that.
So that doesn't count on trusses, like if we have borrowing sport, the truss company's responsible.
That's right.
So we're not expect greater than 2, greater than 6.
Yes. And there's also some new truss stuff in the IRC that handles just that, because people were seeing this and saying, oh, I can't do this, but I want a covered patio outside my house. And so they had put it out there 10, 15 feet, concrete, and then do a nice covered deck underneath it. Well, that's just a huge kite, right? And it now needs to be engineered. I think trusses can now go 6 feet without an engineer. And by that, the engineer's got to go back to the wall, because it's not just the truss, right? If this was a truss, okay, they can build the truss to withstand the upgrade, but then we're going to bolt it here, okay, but what's going to pull the wall? Might lift the whole wall out and take that whole thing out. Okay, so now we got to come back and work on the foundation and stuff like that. Yeah, so they do it. I mean, there's people that make a living designing that type of stuff, and people that build it.
What were you talking
The
about?
center line one. Sean and I had a huge question. Remember the
Yeah,
center
we
line
had a
thing?
bunch of them. I think they were down in the basement.
Okay, did we answer your question, Missy?
Yeah.
Lisa, you had another big
Well,
question you
with
wanted to
Sean,
ask?
we had a huge question about the center line and grabbing
So-
the inside walls from the outside wall and how far to go.
So on your basement, when you're pulling your dimensions, do you go from the inside of your concrete or do you go to the outside of your concrete?
You start your string on the inside of the concrete. Now, you can do both, because you got to think about how a concrete thing's built. I should have erased the wrong one here. Let me put this back up here. Okay, so it's sitting here. Now, there's some things you can't do on the outside. Because let's say right in here, let me draw my thick wall. I have a window. Now, does that window go through the concrete wall? Okay. So when is the window opening built? Yeah, because they'll put these big boards up, right? And they'll support them. And they dump concrete in the top, and then they let it sit, and that forms the wall, right? Well, what they're going to do is they're going to put that wall slab up, and they're going to frame the window in there. And so it doesn't ever get filled with concrete, and then they fill around it. Okay. So they build this window, actually, when they're building the concrete wall. This is something that could come from here. It could. But it really doesn't matter to them which way you go. You might as well stay consistent. What you want to do is come from the inside. Okay? Now maybe I pick this one up on the outside, whatever, and then I've got a wall that comes off. Okay? I want that dimension from the inside, and not of the furred wall, of the concrete wall. Right? Because there's 2 walls here. Right? So you want to pull that dimension from that concrete wall, because that's the wall that's there when the framers show up.
Remember the other question about the dimensioning all the way through?
Did that answer the question, or?
Yes, it did. And so on my upstairs, I've got a portion that I would like to run like, well, I probably just need to show you. I'm not really sure how to explain it very well. In the book we were looking, and I wanted a dimension that would run for this, like this section, because this is all on the same line, but I couldn't find a whole lot of space to put that vertical dimension in there. And so I ran a hidden line with this dimension on it.
No, it's obvious. All you got to do is one of them.
Okay.
Okay,
So I
and
don't
I
need
wouldn't do the cabinet really. I'd probably do the wall.
Okay.
But yeah, also the question was, can you remember he ran it from here over?
Yeah.
And I thought that was too, you know.
So,
That could happen too.
You could do
Okay.
that?
Yeah, you got
But-
a lot of variability there.
and so do you need the hidden line showing that those are all on
No.
the, no?
Because
Okay.
hidden lines are generally used to show things, 2 things. We use them strictly for rods, right, in a closet. Would you do 12 inches off the back wall? You did the rod, right? You hang your clothes on. That's a hidden line. What else is a standard hidden line on your floor plan?
Crawl space.
Like appliances that aren't.
Crawl space access?
Included,
What?
appliances and stuff that aren't included,
Shelves.
That are what?
that aren't included
Okay,
in the house,
so appliances that aren't included in the house?
Like what?
like the washer and dryer.
No, they're not hidden lines. Dishwasher
Oh, I
would be
think I read
because it's
that.
under a cabinet.
No,
Okay.
I said the washer and dryer.
Washer and dryer are
No.
thin lines, they're not hidden.
Cabinets would be.
Upper cabinets,
That's-
upper cabinets are hidden lines.
Shower pants.
Shower pan.
You said the dishwasher.
Oh, shower pans and shower.
So I guess what I'm trying to make the point of here, Sean, is with your hidden lines, you have that meaning, some geometry in your drawing. And so use a center line. If you feel like you have to connect some features, use a center line.
Okay.
Okay.
Lisa and I had saw that in the book, and so I put a hidden line there. But you don't, if it's obvious that those are on the same plane, then you don't have to have that
Center.
line there?
Nope.
Okay,
And you're missing some spaces for a walk-through and a door and stuff, but all those are framed into a wall cavity. That wall's straight all the way through.
okay.
Yep. So you just have to do that one spot, and that catches that entire dimension.
Wow, okay.
Anything else that you see out there? Was it easy?
No.
I have a
question.
Yes, Gabe.
So like, on my floor plan, like if you have two doors that, when you show how they open, they like intersect, you like open one of them like halfway, and like how you're doing.
No, I'd show them both intersecting. Are you talking like a closet door and a bedroom door coming into it? Yeah, that's fine, as long as you're hitting another door. That does happen in situations, so we can't get away from it a lot of times. Now, if you're hitting a cabinet or something, then we need to move the cabinet. And people learn over time when they live in a house, oh, I'm gonna open this door slowly because somebody left that other one open and I keep banging it or something. Yeah, show them both in the open. Might also, when you're talking with your client, be a nice visual descriptor and say, hey, do you want this door moved so these two don't hit? Maybe they say, no, I like it where it's at. That door's gonna be closed up all the time or so. Yes?
So I have some partial walls in mine, so I called them out, but then I realized I should have called out with the height. I mean,
Yep.
so, otherwise the frame's gonna go to the ceiling.
That's right. So it should have a note on it saying wall at whatever height you want to be.
Okay, so I didn't know how to describe it. I just said partial wall, so I just say wall at the height. Okay.
Yep. Yeah. And a technical term for that, I mean, the half wall, pony wall, it's called a lot of things. I think it's
Okay.
actually in your text called a pony wall. Pony wall is a descriptor for any wall that's not true height. Any other questions you had out there? Okay, so my goal in having you turn these in is, one, you get practice at it. Two, I need to really kind of check your geometry. I'm going to make sure your closets are all good, your cabinets are all good, your doors make sense. I'll go through your window and door schedules. I'll do the whole 9 yards on them. It's going to take me a little bit. It takes me a couple hours for each one. So I'll try and catch a couple a day and get everybody that info back as quick as we can. Now, one last thing before we jump into drawing on your elevations is I'm trying to figure out a good time to go out and look at some stuff. I got one is going to go into that building class on Thursday and Friday, and I don't want him to miss it. Andy, you're only here Tuesday, Thursday, right? Just in my own mind, if we gotta let Andy, you miss it, I don't think that's a huge thing. You've seen plenty of buildings under construction. But I'm trying to think of maybe tomorrow, but we're supposed to get a big rainstorm tomorrow, so I don't really want to get out in the mud on this. So let's just kind of play it by ear. But tomorrow, please come dressed for going out to the field. Okay? By that, don't wear any nice footwear. Yes, Kate?
Will it be like first thing in the morning or?
Yeah, we'll leave fairly early. Okay. Because we do gotta get back, you need to be back by what, 11:45 or so? So please come ready for it tomorrow. If it doesn't happen then I don't wanna push it all the way back till Monday. Maybe we'll do another trip maybe next week, and do the site then. I want to make sure you're here for that one, and I told you if you took that class, I would make concessions for it, so. We'll try and get this figured out. I'm going to try and set it up for tomorrow. Okay. But if it's raining cats and dogs, this field is bare with nothing but dirt that we're going to do for our site plan, and so it would be a mess. Robert wouldn't appreciate this when we came back either. So let's just kind of play it by ear. Be prepared tomorrow.
Windy tomorrow.
Yeah.
Windy.
So wind we can deal with, I think. Make it quick when you're building your topographical maps. I'll give you more plans on that. Is the best way just to hit it on Google Classroom? You know, because I was thinking I'd look tonight when I leave 3, 4, 5 o'clock-ish and see what the weather's supposed to do.
Sure.
Okay. So maybe check your Google Classroom this evening, and I'll try and put a note on there whether we're going or not. All right, what I want to do today is kind of advance our elevations a little bit. So I've got these two views shown, where I have the view looking into the back of the house, where here's all the big window wall right here. Haven't put my windows in yet, but I've got the roof shown in the ground. And then I've also got where I'm looking right into the garage. Now I wanted to look at these two views today, because in this view, what we see is we see the deck coming off here and around the back. And I kind of want to deal with the deck a little bit, and we also need to deal with this big shed roof that's coming off in this area. And this will give us a good profile look at that roof. So it'd be a good place to deal with that and how we're going to handle the deck. This view right here will be a good one for dealing with the soil a little bit, because we're going to do a daylight basement where here's the side of my garage. Right in here somewhere I've got to start dropping that soil off to get down to the bottom. And we kind of need to deal with that a little bit and see how this house is going to sit. Now that's going to change a little once we get out to the site, okay? Because we don't know how much that site slopes. Now if you do Google Earth on the thing, you know there is a height thing in Google Earth where it can tell you, and you get on this property, you're going to see we have about 8 feet of fall on this property. Well, our basement has 9-foot walls plus a foot floor cavity above it. So we're about 10 feet from the bottom to our main floor. So we're not going to be able to get this thing all the way in the ground, not unless we bring some soil in. But we need to start thinking about that, and then when we go to the site, I think this will make more sense to you. All right, so first, what should we handle first? Should we handle the deck?
Sure.
Okay. So does everybody have this view kind of dealt with right here? This is the one where we're going to see the profile of the deck? Okay. All right, well, let's go ahead and draw the deck on here. Typically, it's going to be wood. So what we need to know is where we're going to start. Now, you will want, and you should already probably have it, is up here I do have the width of this deck that I can project from off of this view. Okay? Because I'm going to see this part right here in profile, correct? So that's going to give me that. Now I show one step on mine, but this might turn up being 2, 3, 4, who knows how many steps. Okay. We won't know until we get to the site. All right, so first thing, I know that it is coming off of the edge of the house out to this line. So I can project down the edge of the deck right here. So just bring down the edge of it. So from my main floor plan, I grab the edge, pull it straight in. Everybody good? Okay. All right, next thing we want to do is where is the deck going to sit in a height situation? You should still have a line on here that is your finished floor. Okay, that's the inside. Does everybody still have that line? Okay. Can you project it real quick, Majid? If you don't, what you can do is you should have the basement down there somewhere, don't you? And let me just tell you, from the basement floor, it is 9 foot 10 and an 8. 9 foot 10 and 1/8 inch. So if you hit 9 feet, or offset 9 feet, 10.125, just offset up, you'll have that line. Okay, now, do we want our deck the same level as this line? And let me just ask you a quick question, and I think you'll answer it yourself. So let's say I put the deck right here, and then I get a big snowstorm, and that's a snowbank sitting alongside. What's going to happen to the snow? They're going to melt and go right in here? Yeah. So you never take an outside surface and put it as the same level as an inside surface. You are asking for huge problems. Get that thing down below. Remember, this door has a threshold in it also. And now typically when we draw, I come 1 inch below. Now, not always are they built that way, because many times we want it to slide right underneath the threshold, and if I'm doing a, I don't know, a wood deck or something, or a tile deck, then I want that to fall right underneath, and it might be a 1/2 inch below or 3/4 or whatever. But for now, just start where your deck is going to be at 1 inch below your finished floor. That way, if we get some stuff, the snow runs down the wall, instead of pooling right here on that seam, it goes below it and pools and then sheds. And it won't go in the house. So we're going to come 1 inch below that finished floor to start our deck. Now, this is a wood deck, isn't it?
Yes.
Okay, so it will drain through the deck. If it was a solid surface deck, we would have to slope it. By that, if I made this concrete, I would want to slope it so that any water that got on here would then drain naturally. It's a wood deck, it will have slats, right, and holes in between the boards. So it'll just drain straight through the deck.
What's the standard slope? The deck slope?
8 to 1/4 inch per foot. Okay, depends on what they want. 1/4 inch, an 1/8 inch will run water, but it's got to build up head to get over the friction value of water. So 1/4 inch is safe. If you get much more than 1/4 inch, you can feel it when you walk on it. At 1/4 inch, you probably won't ever feel it. It feels level when you walk. Okay, so that's the top of your deck, right there. Now, we're making this out of 2x6s, 2x8s, so we're looking at that board on a side view. So how thick is our deck? It's 1.5 inches. So let's draw that board in. There is my front board. Go ahead and put that on. Now, just to make it look good, let's go ahead and rough some stairs in here. Usually on exterior stairs, whether they be wood or whatever, we're using 2x12s or concrete or something. So we're going to make our tread 12 inches, and let's just kind of throw in an arbitrary 7-inch step. So I'm going to just do an offset down from my top of 7 inches and an offset out of 12. And then get these two to join, and we'll kind of just throw our steps in here. Once I draw one, I've pretty much got them all, so I'll just throw like 3 steps in on profile. So when you do this, 7 inches, 12 inches. And just throw 3 or 4 steps on there. Now, we will have to go ahead and support this deck at some point, but we can walk away from this for right now, because there's no sense in building the support until we know how high we are. What we do know is that I'm going to need something coming up from here. I need a post, because I'm out quite a ways and I'm going to put a roof on top of this thing. So let's go ahead and put a post on there. And I'm going to make mine a 6x6 post. So I'm just going to come off this outside edge right here. And then offset that 6 inches. Now that post, even if I'm using a 6-inch post, will probably be a little bit different than that, but they'll get the idea. I want to show you what we're going to draw here real quick before we go any further to get our shape. So here's what we're going to end up having. Where we're going to have our 6x6 post come up. This is going to match our floor, our ceiling height. And then we're going to do a broken pitch truss on this side. Instead of building an individual shed roof, it would be quite a bit cheaper to do it this way, to have the truss manufacturer do it. So in essence, what we're going to do is we're going to come in here and build the ceiling and then tie that into the original truss so that we can build it. Okay. So this is what we're going to end up with. Let me show you this. So here you can see, here's my vault truss. We're coming down through here. Now we're drawing the elevation, so we only see this outside. We're going to come back and deal with the section view later. Okay. So that's what we're really trying to draw here. All right, so from your outside,